G'day, Tony Webster here. I'm going to go through the 1622 water quality web app, pointing out what data it displays and what information we might be able to glean from that data from the recent wet season. To bring you up to speed, our recently launched web app called 1622 Water Quality displays continuous or real-time data from nitrate sensors that the Queensland Government and various project teams have installed in rivers and creeks around sugarcane growing districts, particularly in the Wet Tropics of Queensland. To complement the nitrate information that comes through, 1622 also displays river height data and some rainfall data as well. Importantly, the 1622 web app is viewed through an internet browser. It's not from a downloaded app from the App Store. You can view it from your desktop computer or from your phone. All you need to do is go into your search and type in 1622.farm. So I'd like to show a few observations from the 2019/20 wet season and have a look at how some of the data that comes from the nitrate sensors can be turned into information that we might find useful. So if we zoom into Mulgrave, on the Mulgrave River nitrate sensor, and we click on the icon here, we can see the trace of nitrate, nitrogen and water level. And by clicking on the max extent button here, we can see the extent of nitrate concentrations over the entire wet season, starting about here in December. So because this sensor is at the end of the catchment and it's very, very definitely tidal here, as you can see by these spikes, the water level doesn't actually mean much, so I'm going to ignore it for this particular sensor. When we look at the nitrate trace, we can see there's very definitely some spikes within the data. And if we move our mouse over those spikes, we can actually see what dates they came up at. So that one's around the 11th of January. Then we've got another one here, which is sort of from the 26th of January through to sort of the 4th or 3rd of February. And then we get another spike happening here, sort of around the 23rd of February, and that one coming through sort of until the 9th or something. If we close that, we can move upstream of that particular sensor and find some rain gauges up here. So we can click on one of those and have a look at how much rain fell upstream of that particular sensor. Now the rain is shown for the past 7 days, and have a look at that. That's pretty impressive. 187 millimeters for the 17th of April. That's a fairly decent rainfall. Now we can only see 7 days worth of rainfall data at a time, but we can use this button up here to scroll back to the beginning of each month. We can go back to March, to February, to January, and then we can use these buttons here to scroll through week by week within the month. So if we have a look at the first week of January, we didn't get very much rain. And if we scroll forward just a little bit, we can see that that first event that we saw, there was a sort of 33 millimeters of rainfall around that first spike that we saw further downstream at the Mulgrave sensor. And if we go a little bit further down through that, we can see the next event was sort of around this end of January period. That was associated with sort of this 51, 36, 8, 25, was there any more? And then we had 143 millimeters at the end of January. That was sort of the next event that saw a spike in the nitrate levels down at the nitrate sensor. We scroll through a bit more, not too much rain, not too much rain. Then towards the end of February, we have a look at this 118 millimeters around the 23rd of February, which I think was another spike that we witnessed in the data there. So if we close that and we go back to the Mulgrave River sensor, we can have a look at those spikes in the data that we've just been talking about when we click it on the max extent that we're just talking about with the lines up with the rainfall. We don't see an increase in the nitrate levels as the wet season's getting right towards the end. So what we're seeing as the wet season progresses, the nitrate spikes are getting lower with the rainfall runoff events. So where does all this nitrate originate from? Well, by witnessing a decrease in the nitrate levels in the streams as the wet season progresses, this would point to a source that depletes as that wet season progresses. This could point to a fertiliser originated source, such as the agriculture catchment around those nitrate sensors. And what about the rainforest as a potential source of nitrate? Well, unfortunately, we don't have a sensor right here at the Mulgrave River near the rainforest, but fortunately, we do have one down near the Tully River. So let's go and have a look at that one. If we close that and we zoom out a little bit and go down to Tully, we can have a look at a nitrate sensor which is up here at the Tully Gorge, where the river leaves the rainforest. Once again, it's easier if we zoom out to the maximum extent of the data. And in this instance, we can see that there was actually no nitrate data collected before the sort of the middle of January, and there's missing data in here. But we can see these peaks, and we can see that they coincide with these river height peaks. Now, this site is definitely not tidal, so we don't have to worry about any tidal influence in this data here. And the river height data accurately reflects when it's been raining upstream of this particular site. And we can see that these spikes coincide with those river height spikes, and we can see what values they get to. Right at the beginning of the wet season, we can see it gets up to about 0.2 milligrams per litre, but then very quickly it gets below 0.1 milligram per litre, and towards the end of the season, these couple of spikes here are sort of only half a milligram per litre, which is a very, very small amount. So we can see that there's a depletion as the wet season goes on at this particular site as well. Now, if we look downstream on the same river, on the Tully River, we can see that we get to another sensor further down here at Uramo, which is on the Tully River as well, and there's a nitrate sensor. Once again, we'll click out to the maximum extent of the data, and we can see that this sensor is the same as the one at Tully, and that at the beginning of the season there's no data there, the sensor wasn't there. And we can see there's bits and pieces of missing data, but there's enough information in there to tell us something. Again, this site isn't tidal, so we can see that the river peaks coincide with rainfall that would have had upstream of this sensor, and they're pretty close to what we saw at the Tully Gorge sensor. Now we can see that these peaks of nitrate levels here are peaking up around 0.3 or 0.35 milligrams of nitrate per litre. So that's telling us that within the catchment between the Tully Gorge sensor and this sensor, nitrogen is being contributed to the river within that. And if we have a look at the land use within that, it's a agricultural land use, and so that land is probably contributing nitrate to the river because we're seeing an increase between the Tully Gorge site and this site. Now, I do want to show you one more station, and I'll do that by using my phone just to show you how easy it is. This time I'll again type 1622.farm into our browser, and I'll zoom in on Mackay and have a look at the Sandy Creek sensor down there. I'll click on the maximum extent button to have a look over the whole wet season and have a look at that. That's quite interesting. You can see down the bottom the water levels. We can see that this side again is not tidal, but we can see that in the early wet season there was a peak around here, a little peak, and that coincided with this great big jump in the nitrogen concentrations up to around 4 milligrams per litre. And as we progressed through the season, when we had these other peaks later on in the year, we certainly saw a little peak on the second event, but by the time we got to these two big peaks down here, you can see that actually coincides with a drop in the nitrate concentrations within the river. And what's happening there is the water's just totally diluting out the nitrate concentrations right back down to zero again. This bit here at the end of the season where there's no rainfall anymore is we can see that the nitrate levels are stabilised around about 0.6 milligrams per litre of nitrate in the water. Right, now I'd encourage everybody with an interest in water quality and nitrogen runoff to go and jump on 1622.farm and have a look for yourselves at the data and the information that's in there. All of the sensor information that I've shown today is from publicly available data. These are Queensland government-owned sensors, and anybody can go to www.1622.farm and have a look at that data there. Now, there are project teams such as Project 25, Canada Creek, WetMIP, where there are additional sensors within those projects that farmers or anyone associated with those projects can go and have a look at, and they'll show additional sensor sites which aren't publicly available. I would strongly encourage anybody that's involved in those projects to go and have a look at those sensors that they can get access to, because often those sensors are put on smaller creeks and drains within the catchments, and there's a much stronger signal at those sites than there is at the end of catchment, like for example the Mulgrave River site there. Look, I hope you found this video useful. Thanks for watching. Now go and jump on 1622 and have a look at the data there.